The goal of this lesson is to take a look at simple probability. Simple probability is the chance of an event to happen, or is it going to happen? And what we do is we assign a number to something. Oh, this thing happening has this chance of happening. It could be written as a fraction, 7 out of 8 chance of happening, or 8%, 40% chance of snow tomorrow. But you have to understand, all the things in this world that could happen, I think, does have a number attached to it. The probability of getting struck by lightning, the probability of a shark attack, probability of winning the lottery, everything does have a number attached. Some we know, some we don't, some we're not exactly sure of. What we do have to understand is the limits, the number limits of a probability. The lowest chance I have of anything happening is 0. If it's 0, it means it can't ever happen. So when people say, is this going to happen? People say, oh, 0% chance. Well, that's not actually true unless we know it's actually not going to happen. Okay? So a 0% chance, or 0 as our number, it can't ever happen, in theory. The highest I can have is a 1, which means it's absolute or certain to happen. It has to, 100%. Now what you have to understand is you have the number line in between the two. So if this is my number line, 0 and 1, dead in the middle would be 1/2, which would be 50%. Any fraction higher than 1/2, working to here, would be more likely. Anything less than 1/2, closer to 0 this way, would be less likely. And again, at half, 50%, what some people would call that is fair. And that's why we flip coins to roll. We flip coins because you have a 50-50 chance of winning. But first of all, you have to understand where we're at as far as things happen. So let's try one. 7 out of 8. Now what you can do here is, okay, where is 7 out of 8 on my number line? It's here. Okay, that's closer to 1. That's definitely more likely to happen. I could have 1/3. 1/3 is less than 1/2. It's over here, so it's not as likely to happen. The other thing you could do is take a look at this, and instead of fractions, you could look at it in terms of percents. 1/2 would be 50%, and you would do 1 divided by 2, get 0.5, move the decimal twice over, and this would be 100%. I can also do the same with fractions here. So I can take 7 divided by 8 and get 0.875, which is roughly 87.5%. If I would round, sorry, that's exactly equal, but that's 87.5%. If I round 88%, that's a pretty good test grade. So 88 somewhere closer to the 100. 1/3 we know is 0.33 repeating, so I would round that to 33.3%. And again, that's not a good test score or not a good chance, so that would be down here somewhere. So again, these are the options as far as what numbers to even deal with. 0 being my lowest, 100 being my highest percent. Next up, I want to take a look at a few different simple items. For example, taking a look at a coin. Quarter is fine. You have one side and another side. So when the problem's actually written out, it would look like this. Capital P for probability. In parentheses would be the event, the thing you're looking for. So let's do this. Probability of getting ahead equals what? What are my chances? We know the answer, but let's take a look how it's formed. Chance of a tail, probability of a tail. Well, when you initially form these numbers, it would be initially formed as a fraction. The bottom number is how many total ways can this thing happen? In general, how many different ways can a coin land? Up top then is going to be how many of the actual event that you want, how many of those do you have? So on a coin I have 2 possible ways, 2 total ways it can land. The event, by the way, the event is what goes in the parentheses, so event is what goes in the parentheses. The event is head. How many heads are on a coin? 1. So my chance of getting a head, we already know, is 1/2. Could I turn this to a percent? Sure, 1/2 is the same as 50%. Tail, chance of a tail. How many total? 2 different ways a coin can land. How many tails? 1. So I have 1/2 and I have 1/2. Simple enough. Now I do want to show you one extra piece with this. If you have all the probabilities of an object, right, there's only 2 probabilities of a coin, 2 different ways it can land. What you can do with the probabilities is you can take them and add them up. 1/2 plus 1/2 is 2/2, which is the same as 1 whole, which we know is certain. Now, does this make sense? If you take all of these probabilities and drop a coin, what it says is you're certain to get one of them. Now that should make sense. If I drop a coin, I'm bound to get a heads or a tails. Guess what? I got a tail. Let's look at a die. So I'm listing out all the events that can happen on a die. Die or simple number cube, numbers 1 through 6, 6-sided. So what's the chance of rolling a 1? Well, let's make my fraction. Total goes on the bottom. How many total sides on a die? 6. The event number goes up top. The event is what's in the parentheses. Well, how many 1s are on a die? Just 1. So it's a 1 out of 6 chance. Guess what? 2 is a 1 out of 6 chance. 3 is 1 out of 6. 1 out of 6, 1 out of 6, and 1 out of 6. If I would take all those 1 6 and add them up, 1 6, 1 6, 1 6, I would get 1, 2, 3, 4, 5, 6. I would get 6 out of 6, which is guaranteed to happen. If I drop a die, I'm guaranteed to get one of those numbers, and I got a 3. So again, total goes on the bottom, event goes on the top. The last one I'm going to look at is a spinner. I'm going to show you on my laptop here in a second. Again, this is okay. The last piece I want to look at is on my laptop. You take a look at a spinner, and you see the different colors. You have red, orange, purple, yellow, green. And I hope when you see this, you say, "Oh, wait, they're not all the same size." So you say, "Okay, what is my probability of each color happening?" Well, where people get into trouble is say 1, 2, 3, 4, 5. 5 different colors, so they say 1 out of 5, 1 out of 5, 1 out of 5, 1 out of 5, 1 out of 5. But this isn't 1 out of 5. This piece is bigger, so hopefully it makes sense that it's going to happen more. So what you can do is understand that it's actually split into 2 pieces. So if I would draw a straight line across, so you'd have to understand that this now is 2 purples out of not 5 pieces, but 1, 2, 3, 4, 5, 6. So now I have 6 pieces. So what would that look like when you go to write out your probabilities? Well, you'd have probability of red is 1 red piece out of 6 pieces. Orange, 1 out of 6. Purple, there were 2 out of 6. So I would write 2 out of 6, and I always want to try to reduce my fractions, which would be 1 out of 3. Yellow was 1 out of 6, and green was 1 out of 6. And again, if I would add all of these up, 1, 2, 3, 4, 5, 6, I would always get 6 out of 6, which is my total event happening, which would be 100% or 1. So again, I just wanted to show you the last example of a spinner where maybe not all the pieces are the same size.